Good day, I'm Sir Jimmy C. Francisco, your science teacher, and today we are going to travel back to the past. So sit back and relax as we travel to the curvature of space and time. The universe is everything, from the tiniest particle to the largest galaxies and to the very existence of space, time, and life. But how it all began? Multiple scientific theories, plus creation around the world, have tried to explain its mysterious genesis. However, the mostly wide accepted explanation is the Big Bang theory. The Big Bang theory states that the universe began as a hot, infinitely dense point, only a few millimeters wide, similar to a supermassive black hole. About 13.7 billion years ago, this tiny singularity violently exploded. This bang, that matter, energy, space, time were all created. What happened next were the two stages of the universe evolution. It covers radiation era and matter era that define key events that help shape the universe. First, radiation era, named for the dominance of the radiation right after the Big Bang. This era has made up of periods. The earliest is the Planck's period. No matter existed at this time, only energy and the ancestor to the four forces of nature, the superforce. Gravity, strong nuclear force, weak nuclear force, and electromagnetism. At the end of the stage, a key event occurred in which gravity split away from the superforce. Next is the grand unification period, named from the three remaining unified forces of nature. This period ended when one of the forces called strong nuclear force broke away. Then, the inflation period. During this period, the universe rapidly expanded, almost instantly grew from the size of an atom to the size of a grapefruit. The universe this time is piping hot, and it turns electrons, quarks, and other particles. Then, the electromagnetic period, when the last two forces, electromagnetic and weak nuclear forces, finally split up. The next period is the quarks period. All of the universe ingredients were present. However, the universe is too hot and dense for subatomic particles to form. Then, the hadron period. The universe cooled down, enough for quarks to bind together and form protons and neutrons. In the lepton and nuclear period, the protons and neutrons underwent a significant change. They fused and created a nuclei, and in doing so, they created the first chemical element in the universe: helium. The universe's new ability to form elements, the building block of matter, created the matter era. Much as the name suggests, the matter era defined by the presence and predominance of matter in the universe. It features three periods: atomic period, galactic period, and stellar period. Expand billions of years, the vast majority of the universe's life expand, and it includes the present day. The atomic period. In this stage, the universe temperature cooled down, enough for electrons to attach to nuclei for the very first time. The process is called recombination. This process helps the universe to form the second element, hydrogen. This hydrogen, along with helium, created the universe with atomic clouds. Within the clouds, small packets of gas have enough gravity to cause atoms to pull together. This cluster of atoms formed during the galactic period became the seedlings of the galaxies. Inside those galaxies, stars are formed. And in doing so, they created the latest and current stage of the universe development, the stellar period. The formation of stars caused a tremendous ripple effect and helped shape the universe as we know it. Heat within the stars caused the conversion of helium and hydrogen to almost the remaining elements in the universe. In turn, those elements became the building blocks for planets, moons, life, and everything we see today. This ecosystem of everything was only possible because of the many stages in the universe development. While countless questions about the origin of our universe remain, it is only a matter of time for a long-sought answer to emerge.